We have done a lab on frame relay, so we know about the advantages of frame relay. We have some good idea about frame relay. Okay. So in this chapter, we are going to describe the fundamental concepts of frame relay, local management interface, LMI operation, PVC. Okay. 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 So let's get started. Okay, frame relay, as you can see here, we have headquarters in Chicago. If we want to do point to point, this means that we need to buy subscription point to point from Chicago to New York, point to point from Chicago to Dallas, to Mexico, to Toronto. This is very expensive. I want to buy it. Okay. So the best way is cheaper to go through frame relay. Frame relay, we have two ways. We can do static map or we can do sub-interfaces. Remember when we divided the physical sub-interface into dot 1 and dot 2. We call this sub-interfaces. Okay, what is the benefit or advantages of frame relay? First of all, it is saving less expensive than point to point or private lines. Okay. Also, reduce number of dedicated devices and equipments. Reduce complexity for network managers. Also, it provides better bandwidth than flexibility. I can control the bandwidth. Okay, lower cost of ownership and better bandwidth utilization. We have two types of virtual circuits in frame relay. We have SBC, switched virtual circuit. It's established dynamically by sending signaling messages to the network, or PVC. These are pre-configured by the carrier. Okay. And after they are set up, only operate in data transfer and ideal modes. Don't forget that. When they ask you about PVC and SBC, put this in the definition. What is DLCI? DLCI is used to identify the virtual circuit. Remember, we said we have DLCI 102 from router 1 to router 2, or 201 from router 2 to router 1. Okay? And they have local significance, which means that the values are not unique in the frame relay. So I can put any value. Instead of 201, I can put 2001. No problem. So don't forget this. DLCI has no significance beyond the single link. Here we have multiple virtual circuits. You can see the green line. We have 319 from router 3 to router 9. And we have DLCI 102. Okay. Here we have a link between router 1 and router 2. So you can have multiple VCs in the same link, but they are distinguishable by DLCIs. Frame relay topologies. We have frame relay star, okay, star hub. So here you have one physical link carrying 5 virtual circuits. That's why we call it star hub. So where is our hub here? This one, Chicago. It's carrying the 5 physical links, okay? One physical link carrying 5 VCs. All right? 1, 2, 3, 4, 5. The other method is called mesh topologies. Each DTE has one physical link carrying 4 VCs. Mesh is more expensive, but it is more redundant. And if one link is down, still I can have the. So they use it for sensitive operations, and maybe military. They used to use it military, maybe in oil fields, like that, you know. Frame relay commands, we have already done that, so I'm not gonna cover this. We have already covered, we have done a lab on this, we explained it. Here we do the mapping, okay. This is a full example here. This is what we have done in the lab. You look here, we have DLCI 203, router 2 to router 3, and DLCI 302, okay. But look at the values here. 3 chargeable components for R1 by Etisalat, by the telecom company. We have local loop, the speed is 64 kilobits per second, and you have 2 ports, 102 and 103, because I have 2 links. And CIR committed
48.
Yeah. Committed internet rate is 48 kilobits per second. Okay, and how much really you have consumed or guaranteed. For the PVC here, we have also values. Okay, DLCI, we have total, and so on. Okay. Configure frame relay, we have done this already. Any questions about configuring the frame relay? Okay. I want to check. This is the static mapping. Anybody didn't do the frame relay lab here? Anybody didn't do the lab? 2 labs?
Which lab?
Frame relay. Static. Yeah, just to confirm, okay. Now this is the command to troubleshoot and verify, which is show frame relay map, okay. It will show you on the router what is configured. Okay. So on router 1, I have one static map to router 2. Okay. On router 2, I have a static map 201, DLCI 201 mapping to router 1. Troubleshooting connectivity, we can do show interfaces serial on the serial interface, and it will show me the LMI value. Don't forget that. So what is the command to troubleshoot the LMI? Show interface in the serial. Yeah, show the serial interface. Okay. And there is another command, show frame relay PVC 102. It will show you the status of the PVC, permanent virtual circuit. Is it active? Okay. And what is the DLCI number? What is the sub interface number? Okay. But look here, please. FECN, okay, 0, and BECN, 0. Okay. We will talk about this later on, so but just remember that. So it has 2 flags, FECN and BECN. Forward congestion notification. This means that moving forward there is congestion. If it is 1, now it is 0. So the link is okay. BECN meaning that I am coming from a congested network. Okay? Yani I just arrived, I'm telling that, Oh, be careful. I came from a congested network. Okay. Okay, any questions about this chapter?
Okay.
Okay, now we will do. We stop.